everyone, just wanted to take a minute to go through the slides on classification of triangles. In class, we went over these slides as well. So in case you missed it or needed to have a little refresher, this will serve to help you complete the notes and answer any questions that you might have. So let's look through what we're dealing with. Today, we're specifically dealing with classification of triangles. And ultimately, our goal is to be able to classify them based on side length and angle measure, because there's two different ways you can classify depending on if you're looking at side length or at angle measure. All right, so again, our objective, we're going to classify triangles based on angle measure and side length. Now, let's look at specifically the angles to start. So obviously, triangles have three angles. And they all must add up to 180 degrees. That is what we had talked about last week with the triangle angle sum theorem. So if all three angles are congruent, okay, so see here, you can see that they have these lines indicating that these three are the same, or you can see with the numbers that they're 60, 60, 60, again, the little marks there, or the 60s, when they are the same, they're called equiangular. So equal angle, equiangular. And you're probably looking at these and going, well, obviously it's an equilateral triangle, which we're going to get to a little bit later. But right now we're specifically looking at just the angles, okay? Because we're just looking at the angles, we're only worrying about the angles being the same. So they are equiangular. All right. Now, if we were looking at this, if there are three acute angles, it is called an acute triangle. Actually, if you think about it, these over here, where they were all 60, they're all acute angles because acute just means that they're less than 90. So an equiangular triangle is also acute. So if an angle, again, if it has three acute angles, since we know they add up to 180 degrees, right? You can see here they must all add up to 180. But because none of these are 90 or larger, again, if one of these was 90, this would not be acute. You just need three that are not less than 90 degrees. We're calling these acute. Now, if there is one angle that is greater than 90 degrees, it's an obtuse triangle. You're probably wondering, well, why can't there be more than one? And again, that just comes from the fact that obtuse angles are at least 90, they're bigger than 90 degrees, right? And we know that all three angles in a triangle must add up to 180. So if we had two angles that were bigger than 90, so let's say we had 91 and 92, and then we have our third angle, we're saying that has to be 180. However, this side, it's already 183. So if we have two angles that are bigger than 90, you're going to exceed your 180 degrees. So therefore, we can only at most have one angle that is bigger than 90 degrees. Okay, so if you have one angle that is bigger than 90 degrees, it's called an obtuse angle. So see here, we have the 100, bigger than 90 degrees, therefore obtuse. 131, bigger than 90, therefore it is obtuse. The last one is if there is exactly one right angle. This is a right triangle. Again, there cannot be two right angles, right? Because if we had two right angles, we've already hit the 180. And that would mean I would have no angle 3, right? The other thing you could think of is if we had two right angles, it would look like that. That's not a triangle. That's just kind of an open figure. Or half a, I guess, quadrilateral. Anyway, so that being said, if we have a right angle, it is a right triangle. All right. So if we're classifying these, we can see right away that if we look at this, we have 60 and 60. because these all add up to 180, so we have 60 plus measure of angle U, that's equal to 180. So this is 120 plus the measure of angle U equals 180. So the measure of angle U here is still equal to 60. So that's why this is equiangular. We could do the same reasoning over here. We could say 60 plus 30 plus the measure of angle E is equal to 180. So we get 90 plus the measure of angle E is equal to 180. Measure of angle E then is equal to 90. All right. So because it's 90, we have a right angle. And because we have a right angle, this is a right triangle. And again, it has to be exactly 90 to be a right angle. It can be very close, but it wouldn't be right unless it's exactly 90. The other thing over here is you'll see that this is equiangular. We also could have called this acute. Equiangular is more specific, but you also would not have been wrong by saying this is acute because all are less than 180 degrees. Okay, so I think those are pretty straightforward. Let's go to classification by sides. So in terms of classification by sides, if it has 3 congruent sides, it is equilateral. So equilateral means 3 sides are the same. Equiangular, the 3 angles are the same. Equilateral triangles are also equiangular. All right, so if it has the same side length, it has the same angle measures. Again, you can look at the tick marks, see if they're all the same, they're congruent. If you look at the measures where they're all 5 here, you'll notice that they must be the same. Okay. All right, let's look at the next one. Isosceles. Now, I'm going to tell you right now, you're probably going to spell it wrong. It's a very difficult word to spell. I spell it wrong all the time. So we have isosceles. Now, we're saying it has 2 congruent sides. It technically just has to have at least 2. So technically, equilateral triangles are also isosceles because it has at least 2 congruent sides. But really, we would just call it equilateral. But anyway, looking at this, you can see that these 2 are the same. Or if you see these 2 check marks, it means they're the same. So isosceles just means that they have 2 sides that are the same length. At least 2 sides that are the same length. And if none of the sides are the same length, it doesn't matter necessarily what they are at this point. We haven't really talked about what are the requirements on the side lengths. That'll come at a later date. But if you have 3 sides of completely different lengths, they are scalene. All right? Scalene. So we had isosceles for at least 2 are the same, equilateral for all 3 are the same, and scalene for none are the same. And again, we're looking at side lengths for these ones. So we have, as a quick, well, we'll do these examples and then we'll do the recap. So if we classify these by sides, we have 2, because there's at least 2 here that are the same. It's isosceles. Because none of these, the 6, the 8, and the 10, are the same, it must be scalene. Okay. Let's do one where we combine them together. So if we have the 3 sides that are the same and the 3 angles, it is equilateral and equiangular. So you can combine these. Okay. So equilateral and equiangular. These ones, 3, 4, 5. Because it has 3, 4, 5, it must be scalene. However, it also has a right angle, so it's also a right triangle. So it's a right scalene triangle, or scalene and right triangle. Again, the 2 marks indicating that they are the same, isosceles, and it has an angle that is bigger than 90, therefore it is obtuse. So you're combining these together to make one big naming system, okay? So to recap, if you have 3 angles that are the same, it is equiangular. If you have 3 angles that are acute, the triangle acute. If you have a right angle, it is a right triangle. And if you have an angle that is bigger than 90 degrees, it is an obtuse triangle. If you classify by side length, if you have three that are exactly the same, it is equilateral. If you have at least two that are the same, it would be isosceles in terms of side length. And then if you have none that are the same, or all three are different, you would have scalene. All right. Please let me know if you have any questions. Have a great day.